Hello there, welcome to new video in software engineering. Today we are going to see unit 3 chapter 2. In that one we are going to see the last part, accessing alternative architectural design, how we are going to design it architecture based on your DFDs. Okay, so mapping of data flow into architecture. Describe the general purpose mapping requirement. What is the main requirement? How you are going to do? How the data flow into software architecture is designed? How they are mapped? DFD to mapping. How information flows? How information flows? How information flows? Mapping approach. There are three types or four types. If you go DFD10, it's just an abstract. You go for online booking of what you call railway. Railway. That's only the date and everything. Then next one, DFD, payment comes up. And more details, what are the payments, how the payments are done, transaction details and all the things. So this is nothing but your abstract. DFD will give you abstract, a little bit detail, more detail as you move down. DFD2, DFD3, these are our more detail will give given to you. So this is part how you are going to design this part. Okay, we have got an architectural process, deriving program architecture, and how we are going to convert this into this one. We are going to see this one. So what are the steps we are going to do? Identify the component, initial diagram, identify the distance component, modules such as responsible for others, relationship, what are the relationship, how the components are flow, how the variously involved, what are hierarchical component, how the hierarchical are related to, border functionalities and other related, refinement of architecture, how it is break down into this one. Then we are going to do with the help of a documentation and diagram. So first identify the component, then relationship, then hierarchy relationship, then move the refinement and remove the unwanted modules and do the documentation. These are the parts what we are going to do. Again, let me move on to next one. This is your transaction diagram. Correct, transaction flow. This is whole flow of diagram. What we have to do it, these are the steps which we are going to do it, but it's not going to be important. Let's see how things work out. You have got a transaction diagram. This is your incoming and this is your transaction center. Incoming, it get divided into different parts. We call it as, once the transaction get divided into different parts, then we call it as transaction center, like your roundabout in traffic or on a signal where different routes are getting connected. So we call this one as transaction center, where different part will be taking out. So when you go on to the transaction state, when the transaction comes up, it break down into different parts and it goes. This is how the action plan goes up. So first identify the transaction one, how we are going to define information flows. Then transaction center, where is the transaction, where the transaction is proceeding, direction of appropriate, where the transaction, it is going to this way, it is going this way, it is going this way, how the transaction goes up, and what are the action path can be taken to it, which are the important part we are taking to it. Identify, determine the key transaction, mapping inflow, incoming transaction, transaction center we have to do, then outline from where it is going to at, what is the hierarchical structure. Correct, you have a roundabout, you're coming here, there are about three parts. Okay, and this is you're coming all the way from Hyderabad and you're going to Vijayawada. Correct, you will take this path. This is called transaction center. This is your incoming and this is your where you are going, important path. So how you, and what are the hierarchical states, means how you are going, coming here from here, what are the steps you have taken. This how it goes up in a transaction hierarchy. The other one, let me go up, we have got a transaction. So this is our top level, x1, x2, x3. What is x1? B, C, and it goes from A to B, C, and then x2 is connected to x3. Where is x3? D and E, and also F. x3 is connected to x1, x1 is connected to x3. So this is your top level, model, then transfer into mapping. X4 is given to GHIJ, correct? Which is not, we are going somewhere else. So once we come up, we'll attach here. So these are all transaction states. Do remember it. This is your top level. We can give one model name X1, we can give model name as Y1, we can give model name as add Z1 or something. This is root model. This is model X2. The transaction comes from BC and goes to A, and model X3, D, E, F, model X4 is this one. This is how transaction mapping goes up. If anybody give you this diagram, you have to convert into this pass. And how many days, how many models will be there? This is main, this is X1, this becomes X2, this becomes, and this is what it is connected to. Correct? I hope you got it. Now next move on to other one. This is your DFD level. What do you mean by DFD level? Detail. Abstract. DFD 0 is abstract. DFD 1 is something about detail. So we have got sensor, monitor. It is going to give you control panel, interact with the user, password is correct, stop active system, configuration information, how monitoring a sensor, it displaying a message. Displaying a message is control panel display, alarm and everything. Monitoring, in this alarm will goes up, and this is a sensor, DFD. Now let's move on to DFD2. I think so, probably DFD2 of what? This one. From here it is coming. Do remember, this is, it is coming your DFD2. So if this it becomes DFD2, more DFD1 is somewhat detailed, DFD2 is more detailed. So let's see. Sensor is coming against the setup, correct? We are not sensor, then we have got monitor. We are about here. Sensor, this one, format of display, generate alarm, dial phone. Is it what? This one? This is what DFD has given to you. This is the part of DFD2 which is given here. And if you go more in this one, as I told you of DFD3, look how it goes. Then it is again divided into this part. This is all how it goes up. Formal display, generate display, sensor information, generate alarm. Then this is alarm, sensor alarming part will come here, and list of select phone number, which phone number, set up the connection, all this will come up. So DFD3 give you more details, correct? And determine the DFD, whether DFD transfer the transaction flow. Yes, isolated the specific incoming one, isolate the incoming. You don't want to go it, you can go for DFD1 or DFD2. This is how it goes up. You have divided mapping of a program, input, and then this comes, middle one becomes your process, this one is your process, and output control. So monitoring the system, input means all those one comes up. Where is this one? Here, input, all this one comes up, your input control panel. And then this becomes your alarm output. What is the alarm output? Phone dial and everything. So we are dividing that. First level of factoring or modeling, that part DFD3 is divided into this part again in a diagram. So you can able to see how software examples will go up. As told you up, making decision model, typically working model. So as you move on, the direction of increase of decision making, as you move up, you go up to decision making. Let's move on. Control panel, as you move up, this is your decision panel. As you move off, decision making goes up. Abstract level of decision will come up. Configuration table, as you move up, but when you are here, how it is going to configuration, as you move on, you move on here, this one, but how it goes up here also same thing. Decision configuration will come into picture. Then second level of abstract, let's take example. I have got this one, map DABC, mapping into founders. First, I'll got a main program, there is a control, specifically control, and rearranging the order. D, it comes to A and C. D, A and C. Where it is coming to D, it is an order. B, it is going to control from where? From this one. So sorry, organize in order. One second, please. Organize in order. This is the part of this one. The major part in this video is that how we are going to convert a DFD into mapping diagram. There are different ways to convert this one, and this is, I told you up how you do refining in the previous slides also. This time is been divided into this monitoring system, alarming, control panel, formal display and everything, then it is general display and everything, how it is defined. Here also same thing, correct? This same thing, and here also monitoring a process, processing control, come down here, processing alarm, processing control, and alarming output, formal display, generic display and everything. How this is your DFD3, DFD3, and how you convert it to this part and how it transfer it, correct? This is one part, sensor input, and this is your control panel which comes, this is the part which comes here, control one, and this is has been transfer and monitoring a sensor, how you are going to do it, how it transfer. This is a basic diagram which goes up with the example. Incoming an action plan, which we have already seen this one, how the transaction flows. Again, review the fundamental parts, understand overall system model including purpose, component and everything, analyzing FDPs, DFDs as to the representative, which level of DFD is there, how you are going to represent it. DFD which is in unit 2, DFD 0 abstract, DFD 1 more 0 abstract plus 1, DFD 2 abstract plus 2a, like this it will go up. Identify the flow of information, series of information, locate the control point, central located point, map DFD structure with your transaction diagram, as we have seen this one, correct? This one, how you map this one. And then factory of refinement structure, refine the transaction structure, ensure that each part is that apply hierarchical rules. Is it not what we have done it in this one? If you move back, is it not what we have done here? Is it right? The same thing what we have done here also. And the last part is this one, how you have done it. Your transaction diagram becomes X1. This is X1. Where is X1? B and A. X1 is B and A, correct? Sorry, X1 directly. Then T, this is the transaction which comes, there is 1, there is 1, there is 1. So this becomes X2. X2 is D, E, F. So if I remove D, X2, I'll go out with this one, correct? If I don't need, if I remove this one, X3 is something like that with G, H, I, J and this one, and I4 is this one. So if I remove at any given time anything about module, this is your module X4, this is module, this is submodule of this one, this is a module, this is a one, and this is what your transaction. If I remove this transaction, everything goes. I want this one, I will not. If I want this one, this one. So this how mapping, and the diagram which I showed you about this one, how it goes up, mapping goes up with this one diagram, which is clearly a small diagram which have, if you write this diagram, this is the which they asked you up. If you write this one, that is more than enough. I have just converted an example here, which is an example which I have shown you about model sensor diagram, which is available to you, and there is a E and F. Where is E and F? Probably D has not given, so I'll write D here. There is one X2, then I, A3, X4. This is one, which is transaction G, H, I, J, it should be K here, and I this one. This part goes up with this one. This is your transaction diagram. I hope you got it out. Thank you. Sorry, one more slide is architectural design. Optimal design does not work for questionable marketable. Does not work for questionable merits. You don't have to questionable. It's just understanding purposes. A refinement, early stage design and counter. You have to refine at early stages. At every stage. Make it simple. Every stage you have to divide, and there is nobody to questionable, because it's just used for understanding purposes. Simple is very good. Strive small number of component. If you do it simple and do it small parts, and do it in small parts, it's very good. Small parts, it's very good, and nobody is there to answerable. It's just for your understanding purposes. Thank you very much. I hope I have covered these points.